In this video, we are going to see how we can develop and simulate the DC motor with these specifications in SIMULINK. So the first thing is to go to library browser. So if I click on it, you have to make sure that you have the SIMSCAPE library. So if I click on SIMSCAPE, so I have two circuits. I have electrical circuit and I have my mechanical circuit for the DC motor. The first thing I need is the source of my electrical circuit, which is the voltage source. So I just need to go to sources, then go downwards, and I will have my voltage source here. So I need my voltage source. So still within the electrical library, I need my passive elements. If I go down the list, I need my resistor, which is the armature resistance, and I need my armature inductance. So I just have to drag them into the workspace. Also for my electrical circuit, I need my ground, which is the electrical reference. So I just need to go to connectors and references, and I will have my electrical reference here. So I just need to bring it into the workspace. So to complete my electrical circuit, I need a transducer that converts the electrical energy of the electrical circuit into the mechanical energy of the mechanical circuit. So for that, I need to go to SIMSCAPE Foundation Library, then go to electrical. Then within electrical elements, I will have my electromechanical converter. So this block converts electrical energy into mechanical energy. So I just need to make my connection for the electrical circuit. So I connect my source to the resistance, then my resistor to the inductance, then I have my inductance to the back EMF. So I have my source connected to the ground and the other part connected to the reference. So this represents my back EMF and the green part represents my shaft. So I need the inertia of my shaft. So to complete my mechanical circuit, I need to go back to SIMSCAPE Foundation Library. Then under Foundation Library, go to Mechanical. Under Mechanical, I need to go to Rotational Elements. Within Rotational Element, I need the inertia of my DC motor. So I'll bring it into the workspace. I also need the damper that I will use to model the viscous friction of my motor. Also, I need my mechanical reference, so I'll bring it into the workspace. So I just need to connect this one here. So for the inertia, let me rotate it. Go to Format. Then I connect it to the R terminal. Let me also rotate my damper. Go to Format. So I need to connect my R terminal and then the C terminal to the reference. So in order to be able to measure and visualize the position and speed of my shaft, I need a sensor. So I just need to go to mechanical sensors, then extract the ideal rotational motion sensor. So let me rotate it. I need to go to Format. Then I will rotate it clockwise. Then let me flip it in order to have it in the right configuration. So now I have my R terminal here, connect it to R. Then my reference here. So in order to know what these two terminals measures, I just need to double click on the block. So you can see the terminals. The first one measures my velocity of the shaft, and the second one measures the position of the shaft. And the unit is in rad. So if you want to change the unit, you can change it to degree or revolution. Also, if you want to measure your acceleration, you can tick on the acceleration, and now I will have 3 terminals, but I just want to measure the velocity and position. So let me now change the values of the components to conform with my specification. For the armature resistance, I have 1 ohms. So by default, it is at 1 ohms. I don't need to change anything. And if the unit is different, you can change it from here. Then for the inductance, my armature inductance, it is at 1 times 10 to the power of minus 6 Henry, but I need 0.01. So I need to change it to 0.01. Now for the back EMF constant, if I double click on it, you see it is at 0.1, but I need 0.01, so I will change it to 0.01. Then for my inertia, I need 0.01 also, so I have 0.01 already, so I don't need to change it. If you want to change the unit again, you can change it from here depending on the given value. So for the damping coefficient, I have 0.001. So if I double click on it, by default it is at 0.001, so I don't need to change it also. So for my voltage source, by default it is at 0 volts, so let me start with 5 volts. The sensors of SIMSCAPE produce physical signal, so in order to visualize it in Simulink, I need to convert the physical signal into Simulink signal, and I do that using the PS2 Simulink converter. So I just need to double click on the canvas and type PS2 Simulink. So this is the block I need. I need 2 of it, so I duplicate it. So the first one here is my position, so I convert it to Simulink signal, and the second one here is my speed, so I also convert it to Simulink output signal. So finally, for visualization, I need my scope, so I double click and type scope. So here is my scope. So as you can see, by default it has 1 input, but I can change it to any number of inputs. So just double click on it, go to configuration, then change the number of input ports to 2. So apply OK. Then I need to connect the signals. I can also name the signal. The first one I know is my position, that is the position of the shaft, and the second one is the speed of the shaft. So I double click on it and type speed. So now I think I'm done. All I need is to use my solver. So I need the solver. So this is what I need, solver configuration, and then connect it here. So the solver is essential in solving SIMSCAPE problem and performing the simulation. So now all is set for my simulation. I just click on run. So after running, I double click on my scope. So in order to know which signal is which, I go to view, then legend. So you can see the yellow one is my position and the blue one is the speed of the shaft. So if you want to learn more about transfer function modeling of the same motor as well as its PID speed control in Simulink, watch the video on the left. If you want to learn more about creating and simulating RLC circuits in Simulink, watch the video on the right. Please like and subscribe to the channel. Thank you for watching.